Good morning class. Welcome back to my channel. I am Namita Sahu. We had discussed about Ohm's law in my last video lecture. So today we'll talk that in the class in Ohm's law we had used resistance as the constant of proportionality. Today we'll learn what is resistance and where comes this resistance from. What is the cause of it? ये resistance कौन देता है और क्यों होता है? Resistance, as the name suggests, resistance is the obstruction offered to the something. So here resistance in Ohm's law, we are talking about resistance, the obstruction offered to the flow of current. So this is the obstruction offered to the flow of current by the conductor. So but now we'll take a conductor and we'll study about the cause of resistance, why this resistance is occurring. So if we take a conductor, we'll see that there are positive ions and there are electrons in a conductor. So these electrons are able to move freely inside the conductor. So they are moving, the arrows that have been shown, they are the electrons that are moving freely. And there are positive ions also, but these positive ions, they do not move. They do not leave their place. They are stationary. So these positive ions are stationary and the electrons keep on moving. These electrons are known as free electrons. You must have read in chemistry also. The outermost electrons, those that have the capability of jumping out of the valence shell. So here we are talking in physics, we'll tell this as free electrons that have the capability to move. So this free electrons, now that there is no net flow of electrons since there is no potential difference applied. So once we apply a potential difference, that is we join this conductor to a battery. So we have joined this conductor to a battery. So it is getting a potential difference. So when this gets a potential difference, the electrons present in this conductor will experience a force. Which will push them from the negative terminal to the positive terminal of the battery. So it will start moving from negative terminal to the positive terminal and there will be a flow of electrons, and whenever there is a flow of electrons per unit time, we say that current is flowing. So as we connect this to a battery, there will be a current flow in it. So what happens when there is a current flow, or we have connected this conductor to a potential difference? So when we connect this to a potential difference, it will experience a force. So and the electrons start moving from the negative to the positive terminal of the battery. So while moving, once the electrons start moving, this is experiencing a force this side. So once it starts moving, what will happen? The electrons start moving. So these electrons while moving will collide with the positive ions that are placed over here. Can you see the positive ions? The positive ions are denoted as in red color. So these positive ions are stationary at their own place. So once the electrons is coming and colliding, so the velocity with which the electrons is coming will decrease. So that's why the electrons do not move from one end to the other end with the increasing speed. They do not move in bulk. That is, one side electrons do not move in bulk. They do not move in bulk. So there is why, because some electrons will get obstruction and some electrons will not get any obstruction. So these electrons which are present over here, they do not get any positive ions in their way. So they do not, their velocity does not decrease. So this electron keeps on moving. But the electron which is over here will experience a collision. So these electrons, they do not move in bulk, but they do so. These electrons which will get collisions, their speed will decrease, and those which do not get collisions or do not get positive ions in their way, they will go on with that same speed. So that's why there is no increasing speed of electrons. So there is a drift in velocity of electrons. So now when potential difference, we know that del V, the change in potential difference, is directly proportional to I. That is our Ohm's law. So del V by I is equals to R, and this R is the proportionality constant known as resistance. Clear? So this resistance does not depend on del V or I. It depends on the number of collisions it makes while the electrons, it depends on the collisions that the electrons comes across while moving from one terminal to the other terminal. Now we will see the factors affecting resistance. So what are the factors affecting resistance? Now the first factor that is affecting is the length of the conductor. What is this L? Length of conductor. Now look at this. So this is the length of the conductor. This is the length of conductor. Now tell me, if I have to go a longer way, if I have to cover a longer distance. So the chances of collisions is more or less? The chances of collision is more. अगर लंबा रास्ता जाना है, हो सकता है दिक्कतें ज्यादा आने की चांसेस लंबे रास्ते में है, तो जितना लंबा रास्ता उतना collisions होने की संभावना ज्यादा है. So that's why, and collisions give rise to resistance, we know. So that's why this resistance depends on length. Resistance is directly proportional to length. If length is more, then resistance will be more. So resistance is directly proportional to the length of conductor. The second factor that is affecting resistance is area. Area of what? Area of cross section. What is this? Area of cross section. So if I am taking, this is the conductor. If I am taking a cross section, so this area of cross section, if I take slit it, the area of cross section, if there is more space, एक broader घर में collision होने के chances ज़्यादा होते हैं या एक narrow घर में collisions के chances ज़्यादा होते हैं? Narrow घर में होता है, क्योंकि space अगर कम है, space जितनी कम उतना chances है कि collision ज़्यादा हो. अगर ये मान लो एक room है, अगर ये narrow है, मतलब इसकी एरिया कम है, एरिया ऑफ क्रॉस सेक्शन कम है, तो अगर नैरो है तो कॉलिजन्स होने के चांसेस ज्यादा है. तो अगर एरिया ज्यादा है तो कॉलिजन्स होने के चांसेस कम है. तो ये कैसे प्रोपोर्शनल हुआ? ये इनवर्सली प्रोपोर्शनल हुआ. जहां पे एरिया अगर इंक्रीज करती है तो रेजिस्टेंस डिक्रीज करती है. So if the area of cross section increases, the resistance of the conductor offered by the conductor will decrease. Now on combining these two equations, what do we get? R is proportional to L upon A. By combining these two equations, what do we get? R is proportional to L by A. So ये proportionality जब भी हम हटाते हैं, we give a constant. So here what constant is given? Here rho is given as the constant. Rho is the specific resistance or resistivity. इस rho को हम क्या बोलते हैं? It is spelled as RHO, rho. So this rho is known as resistivity of the conductor. This resistivity does not depend on another resistance. It is the property of the metal. ये हर कंडक्टर के लिए फिक्स्ड होती है. जैसे कॉपर की अपनी रेजिस्टिविटी होती है, टंगस्टन की अपनी रेजिस्टिविटी होती है. अच्छा मतलब अगर हम बोलें कंडक्टर्स की रेजिस्टिविटी ज्यादा होगी कि कम होगी? ऑब्वियसली कम होगी. सिल्वर इज द बेस्ट कंडक्टर. सिल्वर की रेजिस्टिविटी सबसे ज्यादा कम होती है. और एलॉयज की रेजिस्टिविटी हाई होती है, इसीलिए हम एलॉयज को ही चुनते हैं अपना इलेक्ट्रिकल हीटिंग डिवाइसेस में. हीटिंग डिवाइसेस में एलॉयज का इस्तेमाल किया जाता है और बिकॉज दे हैव हाई रेजिस्टिविटी. नाउ यूनिट ऑफ इफ वी टॉक, तो हमको फॉर्मूला मिल गई रेजिस्टिविटी की. रो इज इक्वल्स टू आर ए अपॉन एल. आर का क्या है? आर का ऐसा यूनिट ओम, और एरिया का ऐसा यूनिट क्या है? एरिया का ऐसा यूनिट मीटर स्क्वायर, और लेंथ की मीटर. सो मीटर मीटर कैंसिल, तो हमको क्या मिला? ओम इंटू मीटर. सो यूनिट ऑफ रो क्या है? ओम इंटू मीटर. क्लियर टिल हियर?